All attendees are in listen-only mode.
Good morning or good afternoon, everyone. My name is Phil Liu, and welcome to our XBOSoft webinar on mobile testing challenges and solutions. Today we have Ed Curran, our VP of Engineering, who will be giving an hour-long presentation, and hopefully it'll also be interactive, where you'll have chances to ask questions about some of his experience that he's been and challenges that he's been tackling over the last year. Ed?
Yeah, greetings. I'm here.
Okay, so yeah, I was discussing with Ed a lot of the material on the slides coming up, and there's a lot of stuff there, and he's not going to read the slides, just like I don't as well, but you will be able to reference it later on. We're going to be posting the slides as well as the presentation on YouTube, and if you have other questions, you can just ask Ed directly via email. Ed? Okay. All right. Well, here's myself. Today's not really about me. I'm the founder of XBOSoft. And here are my specialties here. You can find me on LinkedIn and so forth. But today is really about Ed. And Ed joined us, I guess, about 18 to 2 years ago almost. And he's our VP of Engineering. And he heads up our Applied Engineering group, which is responsible for digging into some of the latest techniques and tools and applying them to our projects. So Ed is in the forefront of this group and leading us and determining what tools we should try, because there are millions of tools out there, of course, and how we should apply them on our projects. And lately he's been doing a lot of work in the mobile area, in performance, security, and various other sub areas of mobile testing. And so hopefully we're going to learn a lot from Ed today. Ed? Ed? Okay. Just a little about...
There's a little delay on the slides. So,
okay. Yeah, just a little about XBOSoft. We were founded over 10 years ago. And we're an international company. We've got offices in the U.S. as well as in China, and we really focus on two things. One of them is software QA consulting, and the other one is the execution of that, of what comes out of that work, which is a lot of times software process improvement work as well as software testing. And next I'm going to go into the house rules. And so everybody is muted today. But you can ask questions to the GoToMeeting panel, and don't forget you'll be getting the recording afterwards. So without further delay, I'll let Ed do his thing, and Ed, go ahead and take it away.
Okay, all right, thanks, Phil. Yeah, as Phil said, I'm Ed Curran, and the Vice President here for the engineering work that we're doing with the XBOSoft software testing. There's a lot of slides here. I'm not going to be going through all of them, but they are there for reference, as Phil noted. With regard to the agenda, we're talking first about a comparison of mobile versus desktop platforms. So we'll talk a bit about the differences and the similarities, and that'll serve as a foundation for us being able to talk about the designing and the testing of mobile applications. And the user experience, localization that we may get to depending on our time constraints for this presentation, and then the testing and automation considerations that are inherent to mobile devices. So the similarities, of course, with regard to the development and with regard to testing, you want to take advantage of whatever similarities there might be between mobile and desktop. And one of the obvious ones is across web interfaces. So to the extent that you can exploit a web interface to be able to render it on a phone or on a computer, you certainly would want to do that. And responsive web design is a technique for doing that. You also want to be able to across data connections via, let's say, APIs that connect to your application. Take advantage of those. So if there's a specific API that a mobile application calls out, a desktop could call on that same one. And while it might be handled a bit different with regard to its presentation, you can take advantage of the connection. And then finally, about across similar code base. So as we're talking about the a similar application or a given application that could be it could be an iPhone application, but it could also be an iPad application. And let's say Xcode as an example, Apple's IDE will allow you to easily test across those different platforms and be able to optimize your code accordingly. So taking advantage of that makes sense. But there's a lot of differences to take into account. First of all, leveraging the similarities provides a simple solution. As we say, why reinvent the wheel if you don't have to? However, there's a tendency to accept similarities that aren't quite appropriate for, let's say, a user experience that might occur on a mobile phone. You could have a desktop with a button, and then you go and render it on the mobile phone, and it's a little bit small. But if you can reuse the code base, reuse the way it's displayed, and not have to recode it, then you might think it's okay. But in fact, it might lend itself to being a poor user experience because it's just a bit too small. The other thing is just the inherent platform-specific functionality, like you're using a mouse for a desktop as opposed to your finger for a mobile device, as an example. Testers need to be aware of these differences. So the list of differences as provided here, we have 8 different items, and I'll just go through these individually. The first one is platform proliferation. And what that is in the case of iOS, there's a fairly limited amount of devices that and how a particular application is going to be rendered on a screen. In the case of Android, however, this diagram shows that there are many different types of Android devices and shapes and sizes that potentially would need to be accommodated if you're writing an Android application. It's over 18,000 unique devices that were picked up in the analysis that created that diagram. And so in Android, it's a far bigger problem than iOS to be able to test against the applications for all the different possibilities of how your particular application might be rendered. This fragmentation, so many choices, can be a strength, it could be a weakness. The strength would be that you'd have many devices that could be accessed. But the problem is it's a big headache for developers because the screen sizes are just to accommodate all of them in an efficient manner it's impossible, and there's prioritization that needs to take place. This is just another view. If you look at the left side, that picture on the bottom, it shows the different screen sizes that are required to be supported by Android. And there's a number of them, as you can see. On the right side, there's just a few for iOS. So the developers are forced to prioritize, in this case, for the Android devices. And we'll talk a bit about how that might occur. And as the developers need to also, as in an agile shop, the developers and testers should be working together. And testers are going to need to accommodate this as well. Another interesting aspect is location. Location is something that exists both for desktop and also for the mobile phones. However, the mobile phones have a lot more interesting things going on because they are on the move. People might go and access their mobile environment, their mobile phone, 150 times a day, and their location's constantly changing. Location-based services on the mobile phone are very useful. Things like navigation, GPS applications for driving, or even a restaurant review where you're actually at the location of the restaurant. You don't have to go and search around. The phone could tell you that this is the restaurant of which you want to review. And another thing that's just worthwhile to mention with regard to mobile design is that within the locations change with regard to their environment for brightness. You know, the varying light conditions, that maybe if you're outside, or if you're inside a car, or if you're inside a building. And so those ambient conditions all need to be considered when you're developing your application. The next one is photography. I think this is interesting. First of all, enabling. The camera is always with you, and so this is something that certainly was a paradigm shift for photography. People don't carry their cameras much anymore. And I have here written, there's no real desktop equivalent for photography, and that's true. You have a camera, but it's not the same thing. Obviously, it's not portable. You can't take it around. You can't easily take pictures. You can do some video. The mobile cameras now are utilized over 10 times over the traditional. It's probably more than that now. And you take photos, but you can also do scanning. Now, while you can have a scanner for your desktop, if we're talking about platform differences, the mobile scanning programs and the cameras within the mobiles allow this scanning to become better and better, where it's just convenient to be able to take a picture of an item using a special scanning piece of application or a special application for scanning. And it very nicely puts it into your, put it into Evernote. That's how I use my phone, using a particular scanning application. This is very convenient. So I used to have a desktop scanner, but I rarely use it. As far as the trends, you could look at the photography, the digital cameras, where they're going down year after year, and then the iPhone sales, which are the phones that really made the impact for the cameras. You can see charted there, and it just continues to increase. And this year will be another increase yet again. So, the photography allows people to go and now, with the applications, enjoy the new social paradigm, where you can quickly take pictures, send it to all your friends on Instagram, Facebook, Snapchat, whatever it's going to be. You have filters to be able to make them look pretty very quickly, or quickly crop them. The requirements for the UI to be supported, if you're developing an application, you would certainly need to be able to access your camera quickly to take that quick shot and not miss a shot that presents itself. You also need rapid storage. So the memory within the phones, along with the capabilities to put the pictures, into the internet, like iCloud, have all been continuing to improve with regard to its capability and speed. Editing photos must be seamless and simple, and so that is another item. I talked about before with regard to the filters. But if it's on a phone, it's just difficult to screw around with if you want to be editing those pictures. Notifications are another item, and I just want to quickly mention this, that the way that notifications are implemented within a particular application is going to directly affect the overall user experience. Large numbers of notifications could be presented within a mobile application. When you install a mobile application, or so many of the applications now are looking to send you notifications. One of the reasons they do that is so that they can draw you back into the application. So even if you're not using it, it's a way to get you back using their application. So it can create a situation where lots of notifications are taking place, or from all these different applications. So they can show up at inappropriate times, and appropriate locations when you just don't want to be bothered with them. So it's always good for the user experience to give the people a choice that's easy to find and easy to change. Now, with regard to content, mobile devices are always with you. They're ideal for digesting content during idle times. So if we talk about the UI design for fast, it needs to be designed for fast access. You want to be able to quickly bring up a news story, for instance. When you're standing in line at the grocery store, if you're going to be there for 3 minutes, you could be looking at the latest news, or looking at a to-do list or something like that. But it needs to be something that can be easily accessed, easily viewed. Large buttons, large gestures. Now, mobile-based research, I put this in because this is my desk. It's similar to the desk at work. It's my desk at home. And basically what I do with this is when I do research, I can do, searches. I can have Evernote up. I can do lots of things on my big screens, two 27-inch screens next to each other on the left and in the center, and then the MacBook on the right. This is very convenient for researching and writing reports, which is a different experience than what would be typically on a mobile device. The mobile device, you're obviously limited by your screen size, and input can be difficult depending on how you're going to do it. Things like Siri, the voice recognition is just, it's questionable, certainly from my perspective. And then if you're going to be typing, obviously that's going to be a challenge as well. Some of the best, if you look at the benefits, customizations, you'll have the localization component, which means that if you're doing research, the localization component can be added into it. So if I was searching for a restaurant, it would know my location and be able to search restaurants in the location where I am. As far as the UI, you'd want a design that has minimum screen input. So you don't have to be doing much with the screen with regard to typing or gestures or what have you. It needs to be intelligent, automatic access of location information, like I talked about. You don't need to type that in. It already knows where you are without you doing anything. But also customization. If you want a different location, as an example, there should be a way to do that. But it should be easy to access. So one thing I just wanted to mention is chat applications and email after this, which are very similar. They all have limitations when you're on a mobile device with regard to input limitations, especially with regard to chatting. While it's always with you to send that quick message, that is an advantage. One trend right now is these mini apps that are in WeChat and Facebook, where there's these small applications that are actually within those applications. So in China, where they use WeChat, you can there might be a whole host of applications that for a user to use, and it exists as soon as you download WeChat. Then you can quickly get those. It's like its own operating system. So that is a trend for some of the chat applications. The application UI for these chat applications, the UI needs to be simple, or should be simple and minimal, with the capability to use canned responses, so that you don't have to go and type them all out. Also, short, multiple interactions on the go. That's about it. Email is the same way. Input methods for typing and so forth. You don't want to be burdened typing long emails because it's just inconvenient. But you should be able to go and do responses and so forth. But the benefits and the customizations, while it's always with you, you have your customized UI, and I could reference Gmail as an example of this. That it's a reduced user interface. A lot of the features are there, a lot of key features, but a lot of the features are not there. Things like a separate chat app that can be put into Gmail interfaces, the way that they present it, Hangouts. So deciding exactly what you want to have within your application is critical to making sure that the user gets what they want, that they get the right experience for the small device, but no more than that. So now I want to talk about testing mobile applications and the challenges in designing thereof. So the user experience criticality, what's important? Localization, which I'm going to skip over, I believe, for now, and if we have time, I'll come back to it. And then testing and automation. So the user experience is essential to the mobile application. And the development thereof is a team effort, from design to coding to testing. If it's an application of any complexity with multiple organizations involved, these things have to be done in a coordinated fashion. And certainly for like an agile development methodology, it would lend itself to that very nicely. It should not just be done or limited to a discrete functional capability. It all has to play. You have an application, it needs to be able to be brought up. You need to be able to get your help menus. You need to be able to go out and get data through a database or online. Everything has to work. It needs to meet the demands of the user and what their expectations for the overall experience. It's worth mentioning that if your application is written and in an effort to support a brand, like in the case of, let's say, a Walmart application, the Walmart branding should be through and through on the application with regard to colors, with regard to icons, whatever it's going to take to go and keep the branding intact and in place. Continuing, the traditional business perspectives apply. With regard to having people that use your application, it's easier to keep them than to go find new ones. And in fact, it's even amplified because the App Store makes it so easy to go and find alternative applications. So you really have to have an application that's put together well from design through solid testing, so the user experience is just excellent. And it creates a much more competitive landscape. And you hear developers complaining about this all the time, with how to exist within the App Store, get to the top, and so forth. It's a real challenge. So the App Store, it simplifies the finding of alternate solutions. And of course, if anybody that's used a mobile phone and downloaded, a number of applications, that within seconds, you can tell if the application, in many cases, if it's, worth your time. So just a couple of statistics here. Localytics, they highlighted a few things. 25% of applications will be used once. 33% of applications will be thrown out after a month, and over 80% after 3 months. And Dimensional Research has an interesting spec of 80% of the app users will try a challenging application 4 times, and then that's it. They're done with it. So getting an app into somebody's hand that is going to really give them what they want and not frustrate them is key to having a successful application. Now, I don't particularly like this graph because it's a little bit confusing, but if you look all the way to the green, you'll see that 23% for travel and lifestyle. And what that means is that 23% of the users are still retained after they downloaded the app 3 months earlier. So this is a 3-month look at the retention for given applications in different types of offerings, from social to business, e-commerce, media. So the great takeaway from this is that none of these particular application categories would exceed 25% after 3 months. So people get into these apps and they just bail if it's a bad user experience. So continuing this user experience dependencies, the UI, it's the first thing people will see. They get their hands on it. It needs to be responsive and purpose-built. You expect it to do something, it needs to do it. And there can't be a lot of obstacles and roadblocks, and no confusion in piloting. So, you're using it. There's some very standard ways that mobile applications need to be developed, and the UI needs to be laid out, back buttons and so forth that are just make it intuitive. And I'll talk more about that in a few minutes. Annoying users' experiences, yeah, that leads to abandon. It's better to have a simple but mediocre app than a comprehensive one that does lots of things, but it's difficult to use. People just aren't going to use it. They're just going to walk away from it. Another aspect is the data speed for mobile applications, and getting data to the mobile application itself can vary widely depending on the RF environments. The modern phones today deal with many different interfaces, from Wi-Fi to cellular to Bluetooth, and they're all there to be supported, but they also have to work within the application properly and be dealt with gracefully. The UI needs to be optimized to provide the view of what's happening to the user. If data speeds are slow, there should be progress bars that are presented. It shouldn't just be a blank screen that's hung up. Something that distracts the user during this slow progress, so it sees something is happening. And that is an important aspect of the user experience and the proper development of an application, because all the applications are going out and they're accessing data. They need to be able to handle it in an elegant fashion. One other thing, and I won't get into a lot of the details here, but if you look at this list, this performance measurements are very important. And once an application is developed, different metrics can be reviewed, including data throughput, screen delays, battery consumption, memory. All those things could be tested. Xcode has its UI test, which was previously quote unquote instruments is what they called it. And Moncop is another tool which can be used for Android and iOS to assist in doing these types of performance analyses. So the design controls, just a couple of notes based on hand position. The mobile devices are unique. It's different than a desktop, of course. It's always with you. It's typically held in one hand, and there's biometrics that are available. So it's more of a personalized extension of you and less of just an independent device. And I think most people, certainly that I deal with today, and I'm guilty of this as well. My device is just with me all the time, and I'm using it constantly. And how many of you would loan your phone to a friend? Well, I personally wouldn't. It's just too personalized with regard to all the applications, communications, all the pictures. So yeah, it's a personal thing. Now, with regard to the phone itself, 50% of the people hold the phone in one hand, and they just drive it with their thumb. 75% of these interactions are thumb-driven. So here's just a couple of layouts of an iPhone showing naturally if you were holding in your left hand or your right hand or in the center, where you might be typing on a keyboard, but how your thumbs could naturally reach into the screen. And it also identifies obviously the hard to reach areas and the areas where you have to stretch. But you want to be working within the natural position as much as you can. Otherwise, it's just an inconvenience as far as the design of an application and its accessibility. The one other thing to keep in mind is that the user experience is formulated by hardware and software together, and they're actually merging. Physical home buttons, yeah, it's a physical home button. On the iPhone, 10, there is no physical home button. It's something different, but many of the phones have physical buttons, but you also have virtual buttons that are built into the interface, and you can position them accordingly. And then you can apply haptic feedback. So even the home button on the latest iPhones, you'd have the haptic feedback even though it's not moving. But haptic feedback could also be applied to buttons on the screen. So it becomes more and more quote unquote realistic. And those things, again, all add to the user experience if they're done well. Let's define interaction. So large gestures are very useful. If you're typing, it's on small areas on the keyboard. Obviously, that's difficult to do, as opposed to a big gesture. Swiping, pressing a big icon. Text input is a small gesture, that's a challenge. Capacitive screens can help with some of the corrective algorithms for fixing text that might be typed in, but it's still not perfect. And it should be kept to a minimum. And I also have written there that you can employ autocomplete for forms. Text size, you don't want to maximize the information that you're presenting on the screen. This idea of design for visual clarity, you want to be able to lay it out nice and clean. The text will be there. It'll be well presented. It won't be too cluttered. And so, because in a mobile environment, like on a bus or on a car where you'd want to take a quick glance, you don't want to be burdened with squinting or having to find things. So the better it's laid out, the better it is for the user. When using the user-facing screen elements, table headings, buttons, help menus, and so forth, the text should be easily readable. So if there is a table that's rendered, it should be well presented as well. Contrast, I won't spend a lot of time on this, but if you have improper contrast, it makes it difficult. It makes it difficult to see something at a glance. It makes it difficult to, especially for people with challenging vision. So picking the right contrast is something that is from a color coordination, it should be right, but the contrast should also be right for a well-presented UX or well-presented UI. Also designed for simplicity. It's got to be purpose-driven. There should be a reason why something happens. Clear view to a primary action. Secondary actions should only take place if necessary. And it should be intuitive. Here's a perfect example. This fidelity application. If you're on the screen to go place a market order, you would see how much. You can put in the information, and it's very clear where you have to press to go next. Preview order. So design to leverage the context-aware sensors also. Design for simplicity means that there's context-aware sensors, which means that certain things that you might have had to type in before, like, gee, I want a map from, Chicago to New York. If you're in Chicago, you don't have to say you need a map from Chicago. It already knows that. And so there's more and more sensors being put onto the phones. The toolkits are certainly incorporating them from the Android development kits to the to Xcode to allow easy access to them, and it eliminates the user to have to go and put in a bunch of data. GPS applications for driving, application knows where you are. Fingerprint and Face ID, which will also have implications for augmented reality. Those cameras. So these are all sensors that are just feeding things into the device so that you don't have to physically do so. And this just shows some of the trends of some of the sensors that have been incorporated. There's more sensors now that are available. But geomagnetic, they talk about a significant motion sensor with accelerometers and so forth that are in that. It's not even listed here, but there's many more sensors than this now. So navigation should be self-evident. All actions should be intuitive, easy to learn, with a minimal of memorization, and easy to use. And in many cases, you shouldn't have to have a help file or anything to be able to go and utilize an application. A lot of these methods are outlined in the human interface guidelines for Apple and design guidelines for the Android developers. And in fact, if you don't follow them in many cases, certainly in the case of Apple, they will not accept the application. So getting a seamless experience across all the devices, development for multi-platforms. Users have expectations that should be duplicated to the best they can across desktop and mobile applications. But there's design considerations, user experience principles. They should be duplicated where possible, but they shouldn't be forced upon the UI. It should be modified if it just doesn't make sense. And a good example of this is just looking at this picture of Spotify, where the user experience on the iPhone is clearly going to be different than the desktop, where the MacBook that's there, and you have an iMac, and then an iPad would be even different. But Spotify does a good job of creating these interfaces such that they're very suitable, much more simple on the iPhone. Many additional things can be put on a bigger screen, and in the case of, let's say, the MacBook. But in the end, a Spotify user has a pretty good chance of being able to navigate either one with little or no problem. The next thing I want to talk about, with regard to some of the testing challenges for the applications, simple applications should be tested and can be tested with manual tests. Test for look and feel, test for usability. More serious applications, the testing needs to be part of the software testing team, part of the software development life cycle, and built right into it. The manual testing cannot be avoided for many areas. There's just no good way to automate certain testing that takes place within certain complex applications. But there are areas that can be automated if properly considered, and we'll talk more about that. So in a manual user experience review, things like right hand versus left hand can be checked. Screen interaction, are there two small items? Visual clarity, like we talked about with regard to contrast, and general navigation through the application. Is it adhering to the guidelines that are set out by Apple and by Google? UX evaluation, the manual methods, they need to be well-planned tests. You can do hallway tests, which means giving the application to people that can walk, down hallways, friendly users, if you will, that could give feedback on a particular application. And the results should be coordinated with the other software development lifecycle holders. Localization is an area I'm going to skip over right now. There's good reference. There's good reference there for anybody with that's participating right now if they want to go check through it. that information is worthwhile for consideration if you're developing applications that need to be used in foreign languages or in other regions than just the United States, as an example. Okay, so now I want to talk about testing and automation. And there's these 8 items that I will cover. So the first is looking at the statistics for the challenges in mobile testing. That was a survey that was conducted by Statista. And what they found is that as of 2017, the biggest complaint was that there was not enough time to test. And the reason I put a box around that is because there's a trend that goes over the past 3 years. It has been increasing, that there's just not enough time to test. And some of this might tie back to all the Android devices, complexity of applications, and so forth. But if you look at any one of these particular items, they're all challenged with regard to what they consider to be important problems for them with regard to testing of mobile devices. And they're almost all the items, with the exception of we don't do mobile testing, exceed 40%. So the mobile testing landscape is changing. Different applications, be the web applications or native, require different testing tools. Numerous device interfaces that need to be supported, and less time to test. Okay, so mobile devices operate in very complex environments. Data speeding from a variety of air interfaces, and they all need to be handled. That needs to be moved. The devices need to move between the services elegantly, especially when the data interruptions are going to occur, and they will occur. And also a need to get you off the cellular service if you can, because that could cost higher fees. So applications should be able to should try to prioritize where they're going to take their data from. API integration to external services, they're getting more and more use, and this is a important item for testing, because a lot of the APIs, and you can consider this with the Internet of Things, they're more prone to errors because they're not as mature, and there's more and more of them. So APIs in particular are something that is creating benefit, but also creating much more challenge to make sure that there's proper operation and no security risks. So one of the problems is that the risk can be underestimated. APIs, some are well established, like Twitter and Facebook, but many are unstable, as I mentioned. And proper evaluation and testing of less mature APIs, it's going to take coordination between the developer and the API service providers, and the testers as well, who can test the API services depending on what they are, to determine their level of security and proper operation. So tool selection, I wanted to talk about for a little bit. There's many things to consider: cost, OS coverage, what you really want to be testing. And while cost is a factor, it's not the most important. Is the application going to do the job? So if you're involved with testing of applications, mobile applications, or you need to have a proper tool. So the list of top 10 tools in 2017 are listed here, and I won't go through all of them, but in particular, we at XBOSoft standardized on Appium. We don't have any stake in it. We like Appium as an open source tool. It does a number of things for us. It certainly can test mobile native applications, be they iOS or Android, which was our key factor. But we found it very capable in our testing. So with Appium, there's a couple of the highlights. There's no need to go and modify the application. The application, as it's been created into an executable, does not need to be recompiled. There's no additional code that needs to go into it. Also with Appium, and I'll show you a diagram in a minute. It's the way that it's designed. It supports most languages and frameworks to write the test. So if you write a test, let's say in Java, to go and test the interface on an Apple application for, let's say, Spotify as an example, you could do the same thing to the extent it parallels within the Android world. You don't have to go and rewrite it. There are some driver details in that, some other configuration, but by and large, you could use the same code base. So there's no need to reinvent the wheel. WebDriver for mobile automation is the standard, and that is what is utilized. It also, being open source, we found that just an added benefit. This diagram kind of tells the story. The test script on the right, or I'm sorry, on the left, is driven through Selenium, and then then it's interpreted by Appium. Appium can communicate through iOS to the iOS device through XC UI test or UI Automator in the case of Android. So the test scripts on the left, you can have similar scripts for each. You don't have to go and rewrite the whole thing. Some of the Appium test engineering requirements support. The tests can be written for iOS and Android using the same API. In this case, what I'm referencing is like the Selenium WebDriver. You can write it in your preferred language because the Selenium WebDriver is going to handle that. And so Java, C# or whatever might be your preferred language would be able to be accommodated. Automation support is also there for hybrids, native or web applications. You don't need the source code. It's continuous integration compatible, so you can use Jenkins to set up those tests. And it runs on Selenium. It runs on Selenium Grid, so you can do parallel testing, multiple testing, or multi-device testing simultaneously to save time, and run the same tests across multiple devices. It works with real devices. It's simulators or cloud services. So device diversity, too many devices. Too many device varieties to test. The employment of analytics helps you solve that problem. So you could use something like Localization or Google Analytics for mobile to actually help whittle down, in the case of Android, where there's so many different devices, the key devices that you want to go focus on. You can figure out the analytics based on screen size, the amount of RAM, CPU, and so forth. This data assists in prioritization and also helps the engineers to ensure that they're prioritizing as well. Talked about what to automate. Manual testing is essential to determine overall user experience, the look and the feel, but it allows you to provide the baselines for tests, to test an application. Those baselines can be brought to bear on automation, which can be a necessary and extremely useful tool, but it's how to prioritize that. certain things should be automated and certain things should not be automated. So what's good to automate? Tests that have been successfully executed, stable areas, pages that are not likely to change frequency, transaction workflows that are not likely to change. All those are good for automation. What's difficult to automate is new features that have without manual testing, complex gestures, no resulting well-defined and expected results. In other words, if it's not clear on what the result's going to be, how are you going to automate that to know if the result is correct? If you're going to be switching across apps, if there's an app that's interacting with another application, that can create a problem also if that's its proper operation. That can be difficult to automate. And then dependencies like SIM cards, cameras, and so forth that could be different across different applications or different across different devices. Test automation script guidelines. When you're making a script, make it small, make it easy to understand, easy to fix, make it fast, so that you can do parallel execution for faster feedback. And that can be arranged through a continuous integration platform like Jenkins. It needs to be interrupted or needs to be independent so that a test can run, but to the best that it can be, it should not be dependent on a previous test. In those situations, you can have a real problem where if one test fails, you can't do the next test. So having independence is very important. Make tests that are repeatable are very good candidates for script automation. Self-checking, no human checking, assertions, in other words, checking for boundary conditions to flag a test that might be providing less than desirable results. So you don't have to do that physically or go in and look. There should be an immediate report on that. And then make the test reusable. So that if there's a particular a function in one test that can be used for another, make it modular. So setting up a mobile test lab is an item that we believe is important. Some of these considerations are worthwhile. Local and remote test lab configurations both have advantages. And they can support large number of devices in either case. It's accomplished through local real devices, local simulated devices, remote real devices, remote simulated devices. All these can be used for testing. A local device simulator is a virtual device. It's not an actual phone, but it's a simulator that can run a lot of the tests that an actual phone would, running the same operating system. The phone's emulated through software. It's the same OS and software in large part. There might be some variations with regard to the RAM and the network speed to that of a real device, but they're typically free. And here's a good example from an Android automation test lab. These are simulators, and it's small writing, but it's just an example that a company called Genie Motion provides these simulators for the Android devices, and you can see the long list of them from Google to Motorola, Samsung, Sony, and they're all available for download. This is just an example of the iOS IDE using Xcode, where you can also utilize the simulators and the mobile tests. So, though using the simulators, I wanted to just explain. This is a typical local test lab setup. It's a simple diagram. So local test configuration, you can have real devices there and you can have simulators, and they're all hooked up through Selenium and Appium. And you can run them simultaneously. So you can run tests, like a particular test on a simulator of let's say, an iPhone 5S and an iPad and an iPhone 7. Those would be simulators, and you could have a real device like an iPhone 6 or an iPhone 8 as a real device, and it'll run them all simultaneously against the web application as this is an example. So these are all parallel tests that can be done. And then this is local, and you have to maintain it. But you can also utilize web-based, cloud-based server farms like AWS or BrowserStack and Sauce Labs. And basically, if you look at this diagram, it's taking the same functionality from this original diagram and just pushing it into the cloud-based server farm. So the simulators, real devices, they're all in the cloud. So this is another option for people that want to test across many devices. A remote device server farm, it's similar to the local software test environment, but the big advantage is you don't have to physically manage devices. Remote real devices, they're typically the most recently available devices. So they're modern phones, and they have to be accessed through the web browsers. So you're not actually holding the phone. It's a mirrored image of the real device. And here's an example of that. So this is mirrored in a local Firefox, but this is an actual real device that is being hosted by BrowserStack. And this is a remote simulated device that is on AWS's device farm. Simulated iPhone running on a remote MacOS Desktop viewed in local Chrome. So this is simulated.
Hey Ed, we're gonna have to wrap up pretty soon, but I think one of the biggest questions that people have is, what to test where. On where would you use simulators locally? Where would you use real devices locally? When is it that you should employ the cloud, and so on? I think maybe you could address that before we close up for today.
Yeah, there's well, this slide here, some of the advantage of local simulated devices. The simulated devices are not, a real device is always the best. The simulated devices, they help supplement a real device pool, and you can have a large array of devices. You don't have to buy all the phones. And you can run them automatically, but there's issues like limited look and feel if it's simulated. Touching a real device on a capacitive screen is a lot different than having a simulator on the on a computer, even if you're driving it with automated testing. And you're also limited. The device, when you're running a test, if you have a real device, each one has its own CPU, so you don't run out of power. Each one of the emulated devices on a computer it's going to require CPU power from that computer, so you can only run so many simulators before you run out of gas. I will say that there is this chart here that talks about the situations and the solutions with regard to when it's best to use a real device or a simulator, and the participants can go through this. It's a 3-page listing of when it's best to use those particular devices. So I believe that would be a good reference, getting back to Phil, the point that you were raising.
Okay, great.
So I'm looking at the time right now, and I know there's a lot of information here, and I think what I would like to do is encourage the listeners that they would be able to get a hold of our presentation, because it's really a reference document as much as anything. In fact, it was based on a document, a reference document that was previously created. And it would probably be a good source of information, including links to some of the device farm information, some of the analytics, and many of the other things that have been referenced within the document.
Okay, Ed. Well, I think yeah, it's too bad that we don't have enough time to go through all this stuff, but we're going to have to wrap up here. I'm sure people have meetings that they've got to go to and so forth. Thanks, everyone, for attending. And our next webinar is on January 28th, I believe, and it's by Robin Goldsmith. Robin will be talking about how to shift Agile, or how to shift QA from being at the end. And in Agile, we say that we're testing all the time, but still at the end, it seems that there's a big crunch, and Robin will be talking about how to avoid that. As Ed said, for this webinar, we're going to be posting it on YouTube as well as SlideShare, so stay tuned for an email follow-up that lets you know where to find these things. And I think that's it for today. So thanks very much, Ed, for sharing your knowledge with us. And thanks to all for attending, and we'll see you next time. Thanks, Ed.
All right, thanks. Thanks, Phil. Thanks for your help.
Okay.